Hope you guys did all right on 10.1. This is going to be lesson 10.2. Hope everybody's doing good. I'm having a great time teaching. As you can see, I'm having fun. Anyway, just kidding. All right, let's go into a review just for a minute on circles and their angles. One thing you have to understand about circles and their angles before we go into this lesson is all angles on a circle have to equal 360 degrees. There's 360 degrees inside the circle. That's the degrees inside the circle. The distance around a circle is different. That is called arc lengths, or in other words, it's called circumference going around the circle. There are some similarities though between angles and arc measures, which we will be discussing today in lesson 10.2, which is arc measures. Okay? Well, you do need to understand how to find some angles or percentages or whatnot in a circle. Every circle has 100%. So this one's dealing with percents, so we're dealing with 100. This one's dealing with degrees, so we're dealing with 360. This one's dealing with degrees, so again, 360. So the total here is 100, the total here is 360, the total here is 360. You just have to make sure you see that and recognize, am I dealing with 100, am I dealing with 360, and so on. Okay. All right. Well, let's just do this one first. If I have these degrees or these percentages already, I want to find the missing amount. Well, the four of them have to add up to 100, so I'm just going to take 100, and I'm going to start subtracting these from them. So minus 34, minus 23, and minus 14. So 29 would be what I came up with, percent, because the total of them has to add up to it. So again, then how would I set up this problem? I'm trying to do it so you guys can see. I would say x plus 34 plus 14 plus 23 equals 100. And all I did was subtract those all, and I got x equals 29. Okay? All right, let's go on to the next one. All right, this looks like a diameter, you guys. A diameter will always be 180. A diameter will always be 180. So I want to be able to find out how much this is. So I know that this y value is 180 because it's half of the circle. It's half of the circle. That's with degrees. If it was with percents, it would be 50. Okay, but we're dealing with degrees. So now how do I find that one? Well, I'm going to go x plus 61 equals 180, which is half of it. And I'll just go 180 minus 61, and I get x equals 119. So x equals 119, and I could double check that by adding all three of them together, and they would add up to 360. Okay? So let's watch this one. Sometimes kids get confused because they see two values the same. Just if they're both the same, then there's two of them. Okay, so let's set up this one. We would go x plus 120 plus 76 plus 94 equals 360. Okay, I'm going to slide this up. So x and x is going to be a 2x plus 120 plus 76 plus 94 equals 290 equals 360. Subtract that from that, so it's 360 minus 290, and we get 70, so 2x equals 70, divide by 2, and x equals 35 apiece. So each one of these are 35. And that's how you would solve a circle. Let me just tell you, when you're doing the problems you do today in 10.2, solve the circle. Solving the circle to me means find every degree inside of it. Once you find every degree inside of it, then you'll learn that you'll be able to find any arc on the picture. Okay? All right, so let's move on to the next little review. This review is finding the value of x that makes each quadrilateral a parallelogram. Well, remember, if these are going to be parallelograms, there's certain rules that apply. All right, well, if this is going to be a parallelogram, we've got parallel lines. These two sides have to be congruent, so I would mark, and then I would just set up 9x plus 5, or sorry, minus 5. 9x minus 5 equals 2x plus 8, and solve for it. So minus 2x, that's 7x minus 5 equals 8. Add the 5, and I'm going to get 7x equals 13, x equals 13 over 7. That's what it would be, because you divide by 7, okay? Any questions on that one? All right, well, opposite angles are congruent on a parallelogram, so my markings would be here. I'm going to do 2 of them. Then I'm just going to set up 6x equals 4x plus 24. Just one moment. And now we can go ahead and solve this. Minus 4x, cancel. 2x equals 24. Divide by 2, and x equals 12. Okay? Any questions on that? All right, well, this one down here, we have two angles that are side by side, meaning they're consecutive. Well, we understand that those will always be equal to 180 on parallelogram, because then these angles, if the two lines are parallel, then the two angles that are closest to each other, not across from each other, the two angles that are closest must be supplementary. Well, remember, supplementary means 180, so we would say 2x minus 15 plus x plus 9 equals 180, and we would work to solve it. So this will be 3x minus 6. We combine these two, and then when we combine these two, we'll get a minus 6 equals 180. Then add the 6. 3x equals 186. We're going to divide that by 3. We get 62. And that would make that a parallelogram. All right, well, the diagonals on a parallelogram bisect each other, meaning they're trying to show you that one bisected at that point. So this point right here is the middle. Well, it's the middle of this and this too, so 2 marks and 2 marks. So now we'll be able to set this equal to this. 3x plus 7 equals 6x minus 1. Just minus the 6x, that's negative 3x plus 7 equals negative 1. Oh, minus the 7, negative 3x equals negative 8. Divide by the negative 3, and x will equal positive 8/3. We'll just leave it like that, okay? So that's a review over how to find different things off of a parallelogram and how to solve the circle, okay? How to solve the circle, find all the angles inside of it, okay? Well, we're going to move right on into the lesson. Finding arc measures. Finding the arc measure is pretty simple. A minor arc is any arc measure that's less than 180. A minor arc measure is any amount less than 180. Because if it gets to 180, then it's a semicircle. If it gets to 180, it's a semicircle. And a major arc is any amount less than 360. But more than 180. Okay, so a minor arc is less than 180. A semicircle is 180 exactly, and a major arc is between 180 and 360. Okay? One thing that you need to make sure and understand is that the central angle, a central angle is an angle that is created with the center involved. So this angle right here is 50 because it's from A, C, B, and C is the center, everybody. And that angle is 50. Well, that makes the arc measure 50. Now, that's not the actual distance. I need to make sure everybody understands this. Arc measure is the same as the central angle. Arc measure is the same as the central angle. But arc length is different. That's something we'll learn later. Okay? And there can be different arc lengths. But the arc measure, the measure of arc, AB, and that's how that's read. Just like, do you guys remember when we learned how to read this? A, B, C. So we're saying measure of angle ABC. Well, then B would be where that vertex is. Okay, well, here's the angle, ACB for this problem. And the angle is 50, so the arc measure is 50. The symbol for arc is an arc above the two letters. You need to be able to read that correctly. It's like the geometry language. Measure of arc AB. Okay, that's how you read it. The measure of arc AB. They're showing you that right there. Central angles. You just need to make sure you understand a central angle has to have the center in with it. The center is where the vertex is. Once you have those angles, then you have the arcs outside of them, okay? All right. If you ever have a major arc, because it's sometimes hard for sometimes kids to understand, well, which way are we going? Well, I'm going to teach you how do you know which way you're going right now. If they ever give you two letters on an arc, sometimes kids are wondering, well, should I go this way or should I just go this way? It's always, if it's two letters, it's always the shortest way there. So AB would just be this way, not going around. However, if they wanted you to go this way, then they will give you three letters, or they would want you to follow the letters. So A, D, B. That's how you know you're going the longer distance. Does that make sense? Well, to find the major arc, you can just take the minor arc and subtract it from 360 to get the major arc if that covers the whole distance. Like I say, I'm going to show you some problems here in a minute that are going to be solve the picture. Once you solve the picture, then you can solve anything you want. Don't try to look at what you're supposed to do first. You solve the picture. I'll show you what I mean. Okay? The number one thing is central angles deal with the center. Okay? Finding all the angles deals with 360. If you have a minor arc, it's less than 180. If you have a semicircle, that would be a diameter. That's 180. And if you have a major arc, it's something bigger than 180. Is that clear? Okay? All right. Here's what I mean by solve the picture. I'm not going to look at any of this right here. Don't even look at your question. Look at your picture, solve the picture. Well, they say in the information up above that R to T is a diameter. So if that's a diameter, then this is 180, everybody. Okay? If that's 180 and this is 110, then this has to be 70. Now I'm showing you what I mean by I just solved the picture. I found all the angles. Now I'm going to show you the arcs. This is 110. This is 70. And this one over here is 180. Now having that information, I can find anything I want over here. Watch. Find the measure of arc, R to S. R to S. Well, it's 110. We would call that minor. And I really want you to start doing that just in your head, even if they don't ask for it. Say what it is. Okay, let's follow the letters. RTS. So they obviously want us to go, that's what I was talking about a minute ago, the short distance. So notice I didn't go R to S that way, I went R to S this way. But here, because there's 3 letters, I follow the letters. R, T to S. R, T to S. Well, that's got to be all of it except for 110. So basically, I can say 360 minus 110. That's going to be 100 and, or should be, or I could do it 360 minus 110, or I can take 180 and add this 70 with it, which would be 250. Either way it works, okay? So I can either do I'll do them both for you. I can go 180 plus 70 equals 250, or I can say 360 minus 110 equals 250. Either way gets you the correct answer. Is that clear to everybody? Either way works. All right, now let's do the last one. RS to T, RS to T. So I want just these two. Well, we know that's half of a circle, so it's 180. Like I said, please solve the picture first, then try to answer your questions. Don't do it the other way around. Don't try to look at here and try to go there. Solve your picture, okay, you guys? All right, let's move on. The arc addition postulate, that's just what we just barely got done doing. You can add arcs together to get bigger arcs, okay? You can add arcs together to get bigger arcs, okay? Let's move on. All right, find the arc measures. Well, I'm not going to attempt that until I find all of my information on my picture. I'm going to solve the picture first. So you ready? Well, if this is 40, this one's 40. If this is 80, that's a central angle, that's 80. If this is 110, then this is 110. So I needed to find the rest of it, so I'm going to take 360 and subtract all of that, okay? So I'm going to take 360, I'm going to minus 40, minus 80, and minus 110. So this one over here is 130, this one's 130. I've now solved the picture. Solving the picture means you found every angle, you found every arc. Okay, let's go find our answers. Here we go. Find measure of arc GE, that's its short way. So the shortest way to GE is these two. I'm going to add those two together. 80 plus 40 is 120. So there's that one, and we would call it a minor arc. I forgot to do that on the last one. Let's go back just a second. So this would be major, and this would be semicircle. All right, I told you I wanted you to do that because it's important. So minor on this one. Okay, GEF. GE to F. I can do it two ways. I can either add up 40, 80, and 110, or I can take 360 away, or take 130 away from 360. I think that one's easiest. 360 minus 130. So 230. So it'd be 120 plus 110 is 230. So like I said, it won't matter which way you do it. And you get 230, sorry. You get 230. Go again. Which is major. And then G to F. G to F, the shortest distance, that's just 130. It's minor. For some reason my pen won't write. And that's it. Okay, you guys? All right, let's take a look at this one. A recent survey asked teenagers whether they would rather meet a famous musician, an athlete, actor, inventor, or other people. The circle graph shows the results. Find the indicated arc measures. Well, let's solve the picture. Arc measures, so this one's 83, that one's 83. This one's 61 degrees here, so 61 here, 79 here, so 79 here. 29 is this one, so 29 is here. 108 is here. So this one's pretty well solved for you right off the bat. Let's go find our arc measures over here. Find the measure of arc AC. Measure of arc AC, A to C this way. So we're going to take 108 plus 29. 108 plus 29 equals 137. That would be a minor arc. Minor. Okay, measure of arc ACD. So let's do ACD. A, C to D. So it's this way. So we're going to go 29, 108, and 83. So 29 plus 108 plus 83. It's 220. And 220 is a major arc. So this one would be a major arc. Minor here. Major here. Okay, we'll do our next one. ADC, A, D to C. So we're going this way, everybody. Follow it. 79, 61, and 83. 79 plus 61 plus 83. 79 plus 81. Oh, sorry, 61 plus 83 equals 223. And that is a major arc. And then measure of E, arc E, B, D. So follow the letters E, B, and D. So we're going this way. I think the easiest way to do that one would be to just take 61 away from 360. So I'm just going to go 360 minus 61. Notice, it doesn't matter which way you end up doing it. You just have to find it. So 360 minus 61, it's going to be 299. And again, that one is major. Okay, everybody? So make sure that you understand that. Solving the picture, that one's pretty quick. All right, let's take a look at this one. It says identify the given arcs and measures as minors, majors, and semicircles. We did that. We've been doing that the whole time, so it's really nothing different than what we've been doing, okay? All right, so let's solve the circle. Number one thing to do to solve the circles, find all the angles. Well, I don't quite know if that's 120. I'm just going to take those three away from 360. Minus 120, minus 60, minus 80. So I've got 100 degrees. Okay, well, if that's 100, this is 100, this is 60, this is 80, and this is 120. All right, the picture's solved. Let's go find our arcs. And then let's tell you whether they're major, minor, or semicircle. Okay, so T to Q. Shortest distance is 120. So that's 120. We would say minor. There's our answer, even though the 120 is helpful too. QRT, QR to T, so QR to T. I'm just going to take that away from the 360. 360 minus 120, that's going to be 240. And that is major. Okay, TQR, TQ to R, it's 120 plus 60, that's 180. That's a semicircle. Okay, Q to S, shortest distance, Q to S. Notice I didn't go this way. I went the shortest way there because there's only two letters. Anytime there's two letters, it's the shortest way there. So it would be 160, which is minor. T to S is 80. That's minor. And then RS to T. RS to T, that's going this way. That's going to be our 180. And that's a coincidence of the 3 letters on that one. Anyway, just add them up. And that's how you would answer that one, okay? All right, we're almost there. All right, congruent circles theorem. 2 circles are congruent circles if and only if they have the same radius. So basically this, as long as the radiuses of any 2 circles are the same, then the 2 circles have to be the same, okay? So here's the counter example of that. So here's how it doesn't work. Let's say I have this and I have a circle and I have that and it's 10. And I have another circle and it looks similar, but that's 8. These are not congruent. These are not congruent because that radius is 10, that radius is 8. Is that clear? So if this radius up here was 50, then that one's 50. They are congruent. Okay? All right, we're almost there. Congruent central angles theorem. Okay? Well, if I have two angles, or if I have 2 diameters that cross each other, I have vertical angles. If I have vertical angles, then the arcs across from them will have to be the exact same anyway. So if this was like 30, then that's 30, then this is 30, and that's 30. That's the way it works, okay? The arcs will be congruent if the 2 angles from the center are congruent. If the 2 central angles are congruent, then the 2 arcs are congruent, okay? All right, let's see whether or not these are congruent arcs. Okay, we need to make sure that you understand something. This picture right here is the tricky one. It's really, really tricky. I'm going to try to show you something that's really important here. Congruent means they're the same length. Okay, congruent means they're the same length. There might be arcs that are the same, but their lengths may be different. I want to make sure you understand that on this one right here. We'll get to it in a second. All right, if this one's 80, this one's 80, this one's 80, and they are on the same circle, therefore they are congruent. So yes, congruent. Okay? All right. Measure of arc, RS. I'm going to point this out. That's 90. Measure of arc, TU, is 90. Would everybody agree? They're 90, they're 90. But RS is not congruent to TU. Not congruent. Now, is their arc measures congruent? Yes. But is their actual length congruent? No, they cannot be. Is that clear? Okay, I have 2 circles. They have the same radius. Therefore, what's their central angle? That's 95. So this is 95. This is 95. Yes, congruent. Does that make sense? That's the only picture that is a little bit tricky. There are concentric circles. Listen, concentric circles do not have the exact same arc lengths, even though they have the same arc measure. Okay? Yeah, this is 90, that's 90, but this distance is not the same as that because their radii are different. The radiuses are different from Q to S compared to Q to U. And therefore, their lengths here are different. Is that clear? That's the only one that's not congruent. All right, let's take a look. Tell whether the red arcs are congruent or not. Well, let's find out. Are the radiuses the same? Yes. So then 145, 145, those are the arcs. I'm going to say yes. Measure of arc AB is congruent to measure of arc CD. And that's the way you would say it. Is that clear? So that's a yes. This one, Okay, let's take a look. This has a 120. This has a 120. But this is a 5 radius and that's a 4 radius. Therefore, no, not congruent. Because if the circles are not congruent to start, their arc measures cannot be congruent. Even though their arc measures are the same, they are not congruent because their radii are not the same. Not the same radius. And it asks for why, so it's because they're not the same radius. And the last one is all similar circles. Circles are all similar because they have the same basic shape. Similar just means one shape's maybe bigger or smaller than another shape. So let's just look back at this problem for just a second. Definitely, this circle is similar to all the circles, but is it congruent to any of those? No. This circle in the inside is similar to the circle on the outside, but is it congruent to the circle on the outside? No. This circle is congruent and same radius, congruent and same radius. Therefore, these two circles are the only two circles here that are congruent and similar. Okay? If you remember, when we think about the word similar, we're thinking one shape's bigger or smaller than the other. Okay? To be congruent, though, you have to be exactly the same. Anyway, I hope that helps you. Remember, solve your circle first, then you can solve the rest of your questions. We'll see you next time.